Hello everyone, in this video I am going to talk about the inverse trig function. Specific the introduction, just the intro for this one. Let's recall what is inverse function. We learned that from Math 141. So let's do a quick review first. Blue pen. Okay, so y equals to x to the cube, which is the cubic function. So the inverse function of that is going to be f(x) prime x, f prime x, or sometimes they write it as negative of f of -1 power to the x. The inverse function of a cubic function is cubic root function. If you don't remember that, we can take another step back to recall how do we find inverse function. So if you're given a function f(x) equals to 3x plus 5, the first step you do is to rewrite f(x) into y, and then the input become output, output become input. So that means you want to swap y and x. So you have x equals to 3y plus 5. And then the next step is solve for y. We want to write the function into y equals to something something. So after you solve that, you will get y equals to x minus 5 over 3. And then you would rewrite this because this is already your inverse function. So f of inverse x equals to x minus 5 over 3. So that's a very quick review of what is inverse function. Okay, let's get back to our cubic function. So what does inverse function to help you? In fact, the inverse function is help you to solve an equation, but we will talk more about that later. So function composition. If we compose an inverse function into the original function, such as we can use the cubic function. So the inverse function is the cubic root of x, and then I want to embed this or compose this into the original function. What you get is going to become cubic root of x to the cubic, which is gives you what? X, because the cubic root and the cubic power cancel each other out. Or the other way around, which is the inverse function and then the original function. So that means we compose inverse function with the original function. So that means we got, well, cubic root of the original function, which is x to the cube power. Still, it will equal to x. So that means, hey, maybe if we embed in the original function with the inverse function, or the other way around, we can solve for x. So that's the idea of that. So we need to be careful when we talked about the inverse function. Some function doesn't have inverse function. So here is the notes. Only one-to-one function, one-on-one function, not one-to-one, has inverse function. So what is one-on-one function? One-on-one function is each correspondent input will have a correspondent output. So that means, for example, quadratic function is not a one-on-one function because if I tell you that f(x) equals to 4, so x could equals to either 2 or -2. So they give you all possible answers. So that means this is not a one-on-one function. In fact, if it's one-on-one function, one way to test it is called the vertical line test. No, horizontal line test, sorry. So we already learned that in Math 141, so I'm going to do a very quick review. So horizontal line test is if you have a graph and then you can find any random horizontal line. If this horizontal line only passes the graph with only one point, which is always one point, that means this is going to be a one-on-one function. But if you have a function such as the parabola, and when you have the horizontal line test with it, you will notice that the horizontal line will intersect with the quadratic function with 2 points. So that means this is not a one-on-one function. Okay, so why this important? Because when you find the inverse function of that, you will notice that the quadratic function doesn't have inverse function. Because this is not a one-on-one function, that means it's not going to pass the horizontal line test. If it's not a one-on-one function, it won't have an inverse function unless we restrict the domain. Well, what does that mean? We restrict the domain. So that means instead of the whole function, we only restrict the domain for all the possible part. So that means if I restrict the domain from x from 0 to infinity, then this is going to be a one-on-one function. Why? Because it passes the horizontal line test. Every time when you have a horizontal line, it only intersects with the original function 1 point. So that means if I restrict the domain of certain function, it can still pass the inverse function. Okay, so that's very important. Why is that? Because if you remember our sine and cosine function, such as sine start with a 0, it look like this way, right? That's our sine function. This is a sine. Sine function is not going to pass the horizontal line test because it has been intersect with sine with more than 1 point. It doesn't pass the horizontal line test. That makes it a 1b. But however, if we restrict the domain, then we might have an inverse function for sine. I'm going to write this down. So sine and the cosine are not one-to-one function or one-on-one function. In order to have an inverse function, we need to restrict the domain. So now, let's assume that the domain are to restrict. Let's see, how do we find the inverse function? So for every sine theta is going to equals to the opposite side over the hypotenuse, right? So which one is input, which one is output? Remember the inverse function is we swap input and output. So the first step for us is to identify the input and the output. Theta, the measure of the angle, it will be our input. And then this number, it will be our output. This is the ratio of the size, right? So remember that inverse function is input become output. So when they swap, we will have what? Well, the inverse of sine notation would be -1. The opposite side over the hypotenuse is going to equal to theta. So that's the swap. We swap the input and the output to find the inverse function. Well, I need you to notice that this is notation problem. Sine -y is not equal to 1 over sine y. Okay, this is notation. The negative is the inverse function notation. Doesn't mean it's reciprocal. I know most of cases if you see a negative means 1 over certain degree, but not in this one. Okay, now sometimes we have a different notation. This is just notation. Sine inverse of x, we sometimes write it arc sine x. This means inverse function. So there's two ways to represent the inverse function. Either you have a little -1 on the top, or you put an arc in front of the inverse function. So for example, if I have a sine pi over 6 equals to 1/2, and the cosine pi equals to -1, and the tangent pi over 4 equals to 1. And I want you to find sine inverse, cosine inverse, and the tangent inverse. Okay, now let's begin. So here's my answer. Since the inverse function, meaning that you swap the input, become the output. So that means sine inverse 1/2 is equals to pi over 6. That's it. Similar to cosine. Cosine inverse of -1 is equals to pi. Or tangent, you don't need to write as tangent -1. We learned a new notation. It's called arc. Tangent 1 is equals to pi over 4. Now, let's talk about what is the restrict domain for sine and the cosine. So for sine, for the inverse function, sine x, x has to be restricted between -1/2 pi to +1/2 pi. For cosine, has to be restricted from 0 to pi, and the tangent, it has to be restricted from -1/2 pi to 1/2 pi. I'm going to explain to you why is that. Because let's start with our sine. We know that our sine function look like this way. And the width is the -1/2 pi to 1/2 pi. We know that 1/2 pi is equal to 1 and -1/2 pi is equal to 0. So that means this part. From here, I'm going to erase the part that is sine from -1/2 to 1/2. So only this part. So what happened to this part? Well, if it's only this part, it's going to pass the horizontal line test. Every time you find a horizontal line, it will only intersect with sine with 1 point. Always 1 point up here. So that's why we want to restrict them from -1/2 to 1/2. Because if you extend those, like complete the whole graph, you will notice that, okay, this is going to fail. Look, the top horizontal line already intersect with the function twice. So that means I just want it to be restricted from -1/2 to 1/2 pi. Okay, similarly to cosine. So we know that the cosine graph look like this one. And we only want this part to use this part, because only this part will pass the horizontal line test. Actually, it can be this part or this part. You have to restrict the domain, or even this part. I don't know if you will be able to see it. This is 3 different colors. Let me highlight this a little bit deeper so you can see it clearly. But the most common one is we always choose the starting point while including a 0. So let's say if we pick this one, well, this is going to pass the horizontal line test, because you can find another one. You can find another intersection point with all the horizontal line, right? It's always intersect with 1 point. So that means the restricted domain is going to from 0 to pi. Tangent is even easier, because tangent is look like this way. So that means the domain is from negative pi to -1/2 pi, and then to 1/2 pi, but not including, because that's the asymptote that we talked about in last week. Okay. So in this case, we need to be careful about the domain and the range for the inverse function. Okay, let me do a recap. So for the regular trig function, we have the domain, which is the measure or the input. The measured of an angle, which is 45 degrees, 60 degrees, or pi over 6, pi over 3, pi, negative pi. These are the domain for a trig function. Its range is a ratio of the side, such as could be the opposite over the adjacent side, or the adjacent over the hypotenuse. So these are the range. But for the inverse trig function, we have the domain become the ratio of those sides, but the range, it will be the measure of the angle. So that's it for today's video. Let me know if you have other questions.